friends, very good morning. Myself Dr. M.A. Channaya, and in this video we are going to work out a problem on the projection of a hexagonal pyramid which is to rest on one of its slant edges on HP, and that particular slant edge is inclined at 30 degrees to VP. Friends, let us see the question for today's video. It reads like this: a hexagonal pyramid of side 30 mm rests on HP on one of its slant edges. So, friends, the moment you see the statement that a pyramid is resting on a slant edge, or a pyramid is resting on a corner, or a slant edge of the pyramid is inclined to HP, for all these cases, you have to place the pyramid on HP such that one of the corners of the pyramid comes to your right side and obtain the top and front views. Now friends, I have placed the pyramid on HP such that one of the sides is parallel to VP, and obviously one of the corner will come to your right side. That's for the observers. Obtain the top view. Top view is going to be a regular hexagon of side is equal to 30 millimeter. I mentioned here. So this will have a dimension 30 millimeter, and here we'll name these corners as A, B, C, D, E and F. O dash is the vertex, O is the uh, top view of this vertex, and OA, OB, OC, OD, OE, etc. represent the slant edges of the hexagonal pyramid. So very obviously we have 6 slant edges OA to OF, and along its lateral surface it has got 6 triangular faces, and all these 6 triangular faces are isosceles triangles. Now friends, if you observe the front view, in the front view you will see that it has a slanted OD, that is O dash D dash, which is parallel to this OD. Since OD is parallel to VP, this is in its true size, and the line O dash D dash represents one of the slant edges of the pyramid which is inclined to HP. In the question it is said that it has to be on HP. So friends, if this is figure number 1, I am going to redraw this figure as figure number 2 with O dash D dash resting on the slant edge. I have shown here slant edge O dash D dash is on HP. So remember friends, this is figure number 1 in the front view, this is figure number 2, and these two figures are exactly identical excepting that it is written at an angle to HP. Now friends, you will mark all these corners, and friends, when you look this from the top, you observe that this line A, B, C, D, A dash, B dash, C dash, D dash, E dash and F dash representing the base of the solid is visible to the observer in the top view. And once again, at this point, you should remember that whenever any pyramid is placed on HP, on one of its triangular faces or on one of its slant edges, the complete base of the solid is visible to the observer in the top view. Hence, friends, I am going to get all these 6 corners by projecting points one by one. For example, A dash. Draw a vertical line from A dash, a horizontal line from here. The point where those two intersect is point A. Likewise, you can obtain B, C, D, E and F, and all these are completely visible to the observer. Hence, I have shown them by visible lines or dark lines. So, in case of the cones, also you will be able to see the complete base, in which case you get an ellipse. A circular base appears as an ellipse in the top view. Friends, I have written this top view, and you can see the axis O1 is parallel to VP. And now friends, you can see here, since the complete base of the solid A, B, C, D, E, F is visible to the observer, the border lines are visible, whereas the line connecting or the the slant edge containing O to E and O to C are not visible. Hence, I have shown them by dotted line. You can see here these two dotted lines. Friends, we'll call this top view as figure number 3. Now, friends, if you observe this slanted O dash D dash is on HP, and that OD representing the top view of the slanted is parallel to VP. But in the question it is stated that it has to be at an angle of 30 degrees to VP. So friends, here whatever the figure you have got here, I am going to redraw that figure such that this slanted OD is at an angle of 30 degrees to VP. This inclination of this slant edge with the VP can be seen only in the top view. Friends, after obtaining this figure, which I represent as figure number 4, and if you compare these two, friends, these two figures are always identical. So this condition is applicable even for the laminate. So friends, we will follow the same procedure and obtain the corresponding front view. Now we will call this as top view, which is drawn using these dimensions, and we will get the final front view of the pyramid. Friends, we follow the same procedure. Start from point A. See, point A is here. Draw a vertical line from a horizontal line from here. These two meet at point A dash. Similarly, B, vertical line from B, horizontal line from B dash. The point of intersection will give you B dash. C, draw a vertical line from C, a horizontal line from C dash, they meet at this point. So in the same line, we are going to get all the 6 corners of the pyramid. Finally, we have to get vertex. So draw a vertical line from O and a horizontal line from O dash. These two intersect at this point, O dash. Friends, we have got the complete front view of the solid when the solid is resting on one of the slant edges, that is O dash D dash on HP. Remember friends, in this case the angle triangular face containing these slant edges, namely O dash E dash F dash, O dash E dash and D dash. Similarly, O dash D dash and C dash, they are equally inclined to HP, and I call that angle as alpha. Friends, this is how we obtain the complete projections of the hexagonal pyramid, which is resting on HP on one of its slant edges, and the two triangular faces containing that slant edge are equally inclined to HP. And friends, this is a very good question and a very important question from the viewpoint of test or examination. Friends, I hope the presentation was interesting. Please go through the complete video. Do not skip any part of the video in between. And at the end of this, if you like this video, please share the information about my video with all your friends without fail. Have a blessed day. Thank you very much for watching my YouTube video.